Hello guys, my name is Talha Salim and my student ID is 210000740.
Hello, my name is Varishi Ramesh Kumar. My student ID is 21001328.
Hi, my name is Nohana Nabila binti Hamidi with student ID 21001167.
Hi, my name is Asril Lahapi. My student ID is 21001221.
Hi, my name is Sarah Farina binti Noor Effendi with a number ID of 20001718.
Hi, my name is Muhammad Afif Daniel bin Muhammad Taufik. My student ID number is 21001160.
Hi, so I'll be presenting about Introduction Principle of Chemical Engineering. So what is chemical engineering? Chemical engineering is the analysis or design of chemical processes of effectively convert materials into more useful materials or into energy. As a chemical engineers, we learn about chemistry, mathematics, physics, and sometimes biology. Besides, chemical engineering has a wide range of jobs such as water industry, food and drink, process plant construction, and so on. So next, there are two chemical processes which are material balance. So material balance states that mass and energy cannot be destroyed or created. There are different types of processes in question, which are batch, continuous, semi-batch, steady state, and transient. While in energy balance, there are two different types of systems, which are closed system. So closed system does not allow matter to enter or leave, but does allow energy to enter or leave. While in open system, no material crosses the system boundary over a period of time. That's all for me. Thank you.
Hello again. I will be presenting the introduction to chemical engineering fluid mechanics. From the word fluid mechanics, the word fluid, which is a substance that continually deforms, but the word mechanics, which means a study of forces and motion. There are a total of three types of matters, which are solids, liquids, and gases. Solids are firm and stable in shape. Liquids are substances that flow freely but is constant of volume. And gases are substances or matters in a state in which it will expand freely to fill the whole container. From what I know, there are a total of two studies in fluid mechanics. Firstly is fluid statics, which is the study of fluid at rest. Secondly is fluid dynamics, which is the study of the effect forces on fluid motion. Finally, is about Newtonian fluids and non-Newtonian fluids. Basically, Newtonian fluids obey Newton's law of viscosity, whereas non-Newtonian fluids does not.
Hello there, it's me again. I'll quickly summarize the process of producing acetone. The process begins in the feed in which the IPA and the feed stream are mixed. After they are mixed, they enter the vaporizer, which vaporizes the liquid. After that, it goes through three components, the heater, reactor, and the cooler. After these three steps, it goes into the condenser to condensate the acetone and the IPA. And lastly, it moves into the splitter, which splits the wastewater with our two liquids. And finally, in the acetone column, acetone is separated by fractional distillation from the IPA. And then the IPA is stored in the IPA column, and the whole process repeats from there, making it cheap and efficient. Now moving on, I will talk about the non-reactive and reactive components. Firstly, in the heater there is no material loss and it only changes the temperature. The reactor, however, has an efficiency of 90% and there is some material loss as heat, but not a significant temperature change. So the molar flow changes. That is from me. Thank you.
The storage tank intended for the storage of acetone is an internal floating roof tank, as this tank is suitable for flammable fluids. As acetone is identified as a fluid of high flammability, the internal floating roof tank is deemed suitable for this purpose. The design of the internal floating roof tank consists of vents located at the upper part of the tank or at the roof to equalize pressure by moving the mobile internal roof. The storage tank composition is made of stainless steel with chromium due to its high resistance towards corrosion, and this alloy is also known to be fire and heat resistant. The stainless steel with chromium tank composition also allows the tank to have tough and adherent properties. Thus, the tank would not easily be deformed when under high pressure. Based on the calculations, it was found that Reynolds number of the fluid is 31,412 and is determined to be turbulent flow. The frictional factor within the pipes is then found to be 0.0064 with a total frictional loss of 1.0455 joules per kilogram throughout the entire total length of the pipes. Utilizing Bernoulli's equation, the ideal work for the pump was calculated to be 305.88 joules per kilogram. However, the centrifugal pump is known to have an efficiency of 70%. Hence, the actual work needed for the pump to pump the acetone into the storage tank is 436.9 joules per kilogram. With the actual work in mind, the power used by the pump would be 3,425.3 watts under the assumption that the volumetric flow rate is 0.01 meter cubed per second. There are limitations to the calculations and design that may have caused the calculations to be less accurate. The limitations include pipe flow within the storage tank, and the detailed area specifications of the plant are not known. As the internal dimensions of the storage tank pipeline is not specified, as this is based on the manufacturer's design, the frictional losses and dimensions of the inner pipes may require additional calculations to determine whether the pump requires higher or lower power. Furthermore, as the area of the plant is not known, there may be restrictions of land usage that may require longer or shorter pipe lengths. This in turn may have caused the length of pipe calculations to be less accurate. Further recommendations to improve calculations is by determining the inner dimensions of the inner floating roof tank according to manufacturer specifications and designing the area of the plant based on location by site visits and using additional operating software.
As a conclusion, firstly I will talk about how is acetone produced. Acetone is produced commercially by the basic raw materials benzene and propylene. The compound element is CH32CO. This means 3 carbon atoms are combined with 1 atom of oxygen and 6 atoms of hydrogen. In our case, acetone is produced by dehydration of isopropyl alcohol (IPA) at a certain temperature. To making it cheap and safe, the IPA column where the leftover IPA is fed to the feed. The next part is, why is the production of acetone important for the market and our everyday life? Firstly, acetone is used in paint remover, which is essential in modern life. Not only that, many of our household cleaning products contain acetone in it. The most important usage of acetone is its usage in medicine, and acetone also used in the sterilizing of medical equipment. Lastly, many of cosmetics today also contain of acetone. Next, I will pass the last part to Hannah.
Thank you, Hasril. I will continue from here. So, how does the production of acetone help the economy? Firstly, medicine makes up a huge amount of percentage in any country's economy. Not only that, but also it creates several jobs across the world. Without the production of acetone, major pharmaceutical companies would collapse, and thus it could possibly lead to the crash of the economy, as acetone is needed in the production of acetone, and selling of medicine is one of the major factors in the economy. To sum up, producing acetone is cheap and safe, so the economy benefits greatly from the exports and the products formed from the usage of acetone. Thank you.